Okay, in this video I'm going to show you how to find the general solution of an equation that has a sine function. In particular, we're going to be looking at this function here, 5 sine 4x is equal to -3. And the very first thing we're going to do is we're actually going to look up the general solution in our formula sheets. So here we go. And this is what our formula sheets look like. Level 3 calculus. This is a 2006 formula sheet. Hasn't changed at all since then. It's the same formula sheet every year. What we're looking for now, there are 4 pages on this. We're looking for the page with all the trig functions on it, the trig formulas. So we'll scroll down and you'll find it on the very last page. And on the left hand side of this page there's a whole host of formulas for trig functions. In particular, we're looking for a section on general solutions, and if you look carefully enough you'll find it at the bottom left hand corner of this page. And I'll zoom in and here we go. Shrink that down a bit. Okay, so there are 3 formulas, one for each of the 3 trig functions. There's one for sine, one for cosine, and one for tangent. At the moment we're looking to find a general solution for an equation that has a sine function. So it's this very first formula that we're going to be interested in. And what this formula says is that if you have an equation that looks like this, where you have the sine of an unknown, in this case it's called theta, is equal to a number, because this alpha symbol that you see here on the right hand side is in fact a number, so therefore the sine of a number is still a number. So if you've got an equation that says the sine of something is equal to a number, then this is the general solution for that equation. So what we're going to do is we're going to copy that as the first step in our working out. Okay, so what we have here is we've got a statement for the general solution, which is this statement on the right hand side here. But we can't apply this straight away to the equation that we have, because the equation that we have, this thing here, 5 sine 4x is equal to -3, does not look like this equation here. Alright, so what we're going to do is we're going to apply a little bit of algebra, and we're going to try and make our equation look like the equation in the formula sheet. In our case, our unknown is x, and the unknown in the formula sheet is theta. So it doesn't actually matter what we call it. What we do need to do is we need to make sure that the left-hand side of our equation has the statement sine of the unknown is equal to something on the right-hand side. So at the moment we've got 5 and 4 that we need to get rid of in our equation on the left-hand side, and we can do that firstly by getting rid of the 5. Dividing both sides by 5, and that leaves us with the equation sine of 4x is equal to -3 over 5. What we now need to do is somehow get rid of the 4 in the argument inside the sine function, and the easiest thing to do here is just to rename that argument with a single variable. So for convenience, we're just going to rename that theta. So we're going to say, alright, let's let theta equal 4x. And now we'll have the equation. Our equation now becomes sine of theta is equal to the number -3 over 5. And if we compare that to the statement from the formula sheet, we can now see that we have our equation now looks like the equation in the formula sheet, and so therefore we can now apply this statement as our general solution. So now we can say that for this equation, sine of theta is equal to -3 over 5, theta is in fact n pi plus negative 1 to the power of n alpha. And a couple of things to be aware of here. Remember that n is any integer, so n is a member of the integer set, which means it can be negative 2, negative 1, 0, 1, 2, and alpha is something that we need to calculate. So if we look back at the formula at the top, we see that the left-hand side of that is sine alpha, so therefore the left-hand side of our equation, this negative 305, must equal sine alpha, which then allows us to work out what alpha is. So to work out what alpha is, we just say, well, sine alpha is equal to negative 3/5, and then we take the inverse sine of both sides to work out what alpha is. And we just punch it into our calculators and we go shift, oops, we go, can I have that first please? Okay, so I go inverse sine, shift, sine inverse of negative 3/5, 3 divided by 5. And the answer is negative 0.644 for 3 significant figures, and that's making sure that your calculator is set to radians mode, because the statement at the top there indicates that everything is in radians, because we're using this formula from our formula sheet, and you'll notice that there are pi's and there are no degree symbols in there, so everything is in radians. And so now our general solution looks like this. But of course, our original equation did not have a theta in it. Our original equation had an x. We redefined our equation so that we could apply the formula from the formula sheet. But we need to go back and rewrite our general solution in terms of x's rather than thetas. So we just got to remember that theta is equal to 4x. So if we resubstitute that back into our equation, we'll get the general solution for x. And what we have is 4x is equal to n pi plus negative 1 to the power of n times alpha, which is in this case negative 0.644. And all we're going to do now is get rid of the 4, and we do that by dividing both sides by 4, and that means everything on the left hand side and everything on the right hand side is divided by 4. We've got a nice clean x on the left hand side, and on the right hand side we get a slightly messy expression, but as long as we don't make any silly shortcuts, it is still a valid one nonetheless. So we've got the original expression we had for theta, but to work out the general solution for x, we just divide all of it by 4, and there's our answer.